So once again, I'm here with Menas Kafatos, professor of computational physics at Chapman University, and we are talking this time about the relationship between space-time, gravity, mass, and the physical universe. First of all, let's just talk about time. How do you define time in physics?
Time in physics is defined in Einstein's theory of relativity as the fourth dimension. We can visualize space, right? We can say, well, we have one dimension, depth, height, second dimension, and width, if you like, is the third dimension. And all the objects we see are three-dimensional. Time is the fourth dimension. Now, how do we experience time? In everyday life, we experience it by the passage of time, so-called passage of time, which of course basically is
Change.
We keep track of change,
Yeah,
right?
we keep track.
We keep track of
change.
change.
Okay.
That's what it is.
So there is in the Greek mythology there is chronos, which is linear time, and kairos, which is relational time. Right?
There is chronos and kairos, or kairos, and kairos is the relative, more subjective process time, so to speak. And
how we experience it.
Which we experience, and chronos is the linear time that physicists talk about in quantum physics, in relativity, everything.
But now we have this new nomenclature which says space-time.
Space-time.
So space-time is basically saying that distance in space is also distance in time, right?
Yes, and in fact, in black holes, you get some weird effects. The space and time can even become intermixed at some point.
And according to relativity, if an object is moving at the speed of light, which is about 186,000 miles per second, theoretically,
yes,
then time comes to a standstill.
Time stops.
And then according to general relativity, when you get very close to a black hole or the gravitational field becomes dense, then also time slows down, and actually in the black hole itself, it stops, right?
At
the center of the black
hole. At the boundary of the black hole, which actually is still not at the center of the black hole.
The event horizon.
The so-called event horizon. Time stops, but not for someone who is falling into the black hole. Mm-hmm. The person falling into the black hole, they would still feel the same way as any other day. The people outside, observers outside the black hole, will never see the crossing of the event horizon.
So both relativity theory and general relativity, special relativity
and general relativity, yes,
both suggest that actually there is no chronos. The experience of time is subjective, and in the deeper reality, which is beyond space and time, but non-locality, there's no time or space.
In fact, what seems to be the limiting of the chronos, or the linear time, seems to be a limiting situation where far away from highly curved space-time, like a black hole, or if you're not traveling with speeds close to the speed of light, then time appears to move linearly, and this is how we do physics. But in fact, in reality, really, if you like, everything is a process time.
Yes, but at the heart of it all, at the most fundamental level of it all, past, future, and present are all part of the fabric of space-time as a potential.
They're all part of the space-time continuum, as relativists call it, and it is, if you like, the background on which events take place. And in Einstein's theory, both its special and general relativity, he was talking about events, things happening in space and time, which get recorded by observers.
In their consciousness.
Well, presumably, of course, in their consciousness.
Yes. Okay, now let's go a little further. It's the curvature of space-time.
Yes.
Which to me is a non-visual experience.
It's definitely non-visual.
Okay, but it's a mathematical expression. It's
Right.
the curvature of space-time that gives rise to gravity.
Correct.
And gravity, of course, gives rise to mass.
Gravity gives rise to mass. Mass affects gravity. They are into a direct complementarity, one-to-one relationship.
So mass and gravity are, in a sense, inseparable.
mass and gravity are inseparable.
And they, in turn, are the result of the curvature of space-time.
Correct. And actually, we should probably use Einstein's own words. He said that basically mass tells space how to be curved, and curved space-time tells mass how to move.
Okay.
So they're directly related.
Directly. And they're all coming from this unmanifest field, which is spaceless, dimensionless, timeless, and giving rise to the whole universe.
They presumably come from this unmanifest field, which at some point appears or manifests as what we call the space-time continuum.
And becomes the perceptual experience of objects in three-dimensional space.
Moving in space-time, doing some things, and those recordings on when something happens, we call it an event. Mm-hmm. So basically, this theory of relativity is a situation where you have many events, they're observed by observers, and they record, and that's
Menas, in physics, what you're saying is that the physical universe comes from an invisible domain, which is pretty abstract. It's space-time, curvature of space-time, and then a field of infinite possibilities, right Correct. At the heart of it, right?
Correct.
Infinite possibilities, omnipresent, omnipotent, omniscient, because non-locality precisely means that.
Correct. Although in the theory of relativity, non-locality doesn't really enter the picture per se, but of course in quantum theory it does enter.
Okay, so essentially we are giving a physics, cosmological, relativistic framework for how the abstract invisible becomes the concrete visible.
Correct.
And you're saying to me, at least you're suggesting, that the universe is more mind-like than machine-like.
The universe, because it doesn't really have a substance per se. The substance, according to Einstein, is nothing more than a curvature of space-time. So it's very abstract, right? It's not material. And in fact, that is one of the big problems with physics today, is that the theory of relativity and quantum theory have not been unified yet.
To me, what you've described is how the womb of creation, the cosmic mind, or God, actually becomes the physical universe. Would I be exaggerating that?
It would be, again, perhaps a poetic way to put it, but actually quite accurate in many ways.
Thank you, sir.
Thank you.